Problem 2. Given f of x y equals to 1 over a times y squared times x, y greater than or equal to 1, and x greater than 1 over y and less than y. Question 1. Draw the non-zero definition region of f of x, y. Because x greater than 1 over y and less than y, so we can draw x equals to 1 over y and x equals to y. And they intersect at 1, 1. Because y greater than or equals to 1 and x greater than 1 over y and less than y, so the non-zero definition region of x of xy is here. So we can get integral 1 to infinite, integral 1 over x to y, 1 over a y squared x times dx dy equals to integral 1 to infinite, 1 over a times y squared, integral 1 over y to y, 1 over x times dx dy equals to integral 1 to infinite, 1 over a times y squared times log x, 1 over y to y dy equals integral 1 to the infinite, 1 over a y squared times log y minus log y 1 over y dy. It's equals to integral 1 to the infinite, 1 over a y squared times 2 log y dy equals to 2 over a integral 1 to the infinite log y over y squared dx. So that log y equals to m, then y equals to e to the m. So 2 over a integral 1 to the infinite log y over y squared dx equals to 2 over a integral 0 to infinite m over e to the 2m d e to the m equals to 2 over a integral 0 to the infinite m over e to the 2m times e to the n dm equals to 2 over a integral 0 to the infinite m over e to the m dm equals to 2 over a negative 2 over a integral 0 to the infinite m de to the negative m equals to negative 2 over a times m to the times m times e to the negative m 0 to the infinite minus integral 0 to the infinite e to the negative m dm is equals to negative 2 over a times 0 minus 1 equals to 2 over a equals to 1. So we can get a equals to 2. Question 3. Find and draw the marginal density functions f of x and f of y. F of y equals to the negative infinite to the infinite f of x y dx. Integral 1 over y to y, 1 over 2 y squared x dx equals to 1 over 2 y squared integral 1 over y to y, 1 over x dx equals to 1 over 2y times log x 1 over y to y equals to 1 over 2y squared times log y minus log y to the negative 1 equals 2 log y over 2y squared equals log y over y squared. So f of y equals to log y over y squared for y greater than or equal to 1 and equal to 0 for otherwise. the graph is for x greater than 0 and less than 1. F of x equals to integral negative infinite to infinite f of x y dy is equals to integral 1 over x to the infinite 1 over 2 y squared x dy equals to 1 over 2x times negative 1 over y 1 over x to infinite equals to 1 over 2x times negative 0 minus x equals 1 over 2x times x equals 1 over 2. For x greater or equal to 1, f of x equals to integral x to the infinite 1 over 2 y squared x dy equals to 1 over 2x times negative 1 over y x to the infinite equals to 1 over 2x times negative 0 minus 1 over x equals to 1 over 2x times 1 over x equals to 1 over 2x squared. So f of x equals to 1/2 for x greater than 0 and e less than 1, and equals to 1 over 2x squared for x greater than or equal to 1. The graph of f of x is for f of y, integral negative infinite to the infinite f of y dy equals to integral 1 to the infinite log y over y squared dy. Negative log y plus 1 over y 1 to the infinite is equals to 0 minus negative 1 equals to 1. So f of y is a valid density function. Integral negative infinite to the infinite f of x dx equals to 1/2 plus integral 1 to the infinite 1 over 2x squared dx. It's equals to 1/2 plus negative 1 over 2x 1 to the infinite equals to 1/2 plus 0 minus negative 1/2 equals to 1. So f of x is a valid density function.